Let us discuss about an example. We need to know about the fitting. If you have a data of the variable, and I need to fitting and define the best simulation or best probability distribution that will be used for. Okay, so example, per example, x and y assumption, and define z, y plus x. Assume x, it will be 100, whatever, and assume the assumption it will be, for example, he make reset for the previous one. What happened here? If we make a run and even close the Excel sheet, you should guarantee that every run done before for any another example should be closed, and you make reset to make new example. Okay, so we need to take care about it. It's very good that happened now. Here we define here the assume normal distributions. Okay, when you have a normal distribution, he takes this value as a mean and they take around 10% as a standard deviation. But as I know from as we discussed before, what about the distributions that you have? What's the average of the variable? What about the coefficient of variation? Or if you have the standard deviation, so it will be your input here. So I assume the x variable, it will be by this data. What about the y? Y, it will be from this data. I don't know its probability distribution, but I know this is the data that we have from the back experience for this variable, and I need to define what about the variable. I think here the average, it would be around 25. I know from where I know by sensing, I know this data. I choose here define assumption. Here's the lower icon, which a fitting. Fitting here, it will be a range. I take the range from here. This is the range that I have. Okay, this is the data that I have. Okay, so in any way, it will be range. It will be a text file. If we have a text file to extract that, if you have a huge data, if you have a huge data and you need to mix the rating, maybe a text files you have, but I prefer to be an Excel sheet and be arranged as I presented here. This is the data from where? The data again as you defined before from this variable. From your back history, that you have the data back history for this variable, which in our case it will be y. Here, what about, we take about auto select, whatever it will be continuous discrete choose, but as we discussed before, there are difference between continuous and different between a discrete. Okay, so in any way, here a normal distribution as a case, but here all continuous. Assume this variables, it will be continuous. As we mentioned before, it is, for example, it will be like price of the oil, like the length of the person on the building, can be any number. Okay, but in case of the number of the car, it will be one car or two car or three, cannot be 1.5 car. Okay, so if the car or something like this, it will be a discrete, but in our case, which is a variable, it will be continuous and called probability density function, and if you refer to the textbook. Show goodness of fit statistics. We have many type of analysis that we discussed before, which Anderson-Darling, KS semi-growth, iteration, chi-square method. Define about for everyone what about the best figure by using this criteria. Mention, okay. Here is the data. View cumulative frequency. View here we have here is the cumulative, here is the probability. He mentioned here by this number that when you go to the beta distribution, it will be the best probability distribution that match with your data. According to Darling, it will be 246, which is the lowest number. Here KS 118 chi-square 5385. Maybe there is difference between one method and another method. But anyway, we have two methods provide us it is the best alternative or best matching between this distribution and the data that will be provided. When you increase this data, the better it will be the better estimation of the best probability distribution. So when you increase the back history data, it will be very, very better to define about the best probability distribution that we have. The second distribution is available distributions, then log normal distribution, BERT, beta BERT, normal distribution, gamma, logistic, and so on. Okay, so I mentioned here, okay, beta, I accept it to be a beta distributions. If you need, okay, I need to another one to be considered, to be accepted, and so on. But here, assume it will be a beta distribution. Here, for example, this in case of the beta distributions. Here's another one, it will be the Weibull distributions. The another curve relation between the cumulative and this data. Next one, log normal distribution. You can see about the probability and cumulative. Take care about this curve and the data, and so on. Until we have logistics, so the differences, it will be very high. In case of exponentials, it will be another variables, and so on. Okay, so we assume that the best one, it will be the beta distribution. I make accepted. Okay, he mentioned, okay, this is the beta distribution that you have, the minimum value, the maximum, the beta, the alpha, and so on. I extract this data from statistics of the data that we have. I mentioned, okay. Here define what about this equation, just a simple, it will be this cell plus this cell. Okay, and they make it will be define forecasting, it will be summation z minus x. Okay, have known unit. If you need to make a unit, dollar, LE, sterling, whatever, volume, code, strength, load, whatever, the unit should be here. Mention will be okay. And then you make the run that you have. So I make a combination between the two variables that we have. Okay, as a normal process. Okay, so, and also analyze this variable with zy plus x as you need according to the probability of P10, B12, whatever you have, as we discussed before, it can be defined very well. Okay, so this is the method. If you need to have a fitting for the data that we have, a back history data that we have. Okay, now we have another thing which is very important about to define relations, y and x. We mentioned that in most cases it will be a random number. So if you go through a reset, for example, here it will be 100. The next step, it will be 9925. Here 100, it will be the same 25, whatever, 93, and so on. So there is no relation between these two variables. This can be increased, this can be decreased, or this increase, this increase. So independent variables. There is no relation between these two variables. Okay, but here I make reset. Here we have another assumption. We have to define according to the defined correlations. What about defined correlation? This is the x, add assumptions, y. Okay, so what's the correlation between these two assumptions? This is value, it will be the relation between these two from 1 to minus 1. Okay, from 1, this is a variable here, from 1 to minus 1. Okay, this is the coefficient that will be here. Here relation between show correlation of the assumption x with related to the assumption y. Okay, what mean here? For example, in case of the earth, when you digging inside the earth, when you increase the digging, the temperature it will be increase. For example, okay, as a phenomenon, natural phenomenon, when you digging in the earth, deep to the earth, until to reach the crest of the earth, every depth it increases the temperature. It's a phenomenon. So it cannot the random number here increase and here decrease. Okay, when I assume x, which is the depth of the drilling, and y is the temperature, cannot x increase and y decrease. It is not logic. When x increase, y should be increased in this phenomenon. When you make a digging inside the earth, okay, and also another phenomena when there will be a relation between them. Relation between them, it will be a variable. Can be from 0, there is no relations, here to be -1, which is the direct restriction, this increase, this decrease, or where it will be increased, the another one, it will be increased as well. Okay, and also maybe have a coefficient in between 0.5, 0.4, 0.39, and so on until you have your data. If you assume that when you increase this value x, it will be y around increase 0.5 of x or decrease minus 0.5 of x. Okay, so it will be a relation between these two numbers. And you assume in our case it will be transitive. When it will be increased, the another one it will be decreased as a rule of thumb. We mentioned already. Okay. Step by step, 125. Here, when this increase 107 from 100, this it will be decrease. Okay. Here increase, here it will be decrease. From 25 it will be down. Next one, and so on. When decrease, decrease, and so on, in the same limit, to then step by step. And when it will be decrease, this increase, because reverse between each other. Okay, increase, decrease, decrease, increase, and so on. As I mentioned here in the correlation, I already defined the correlations. From these correlations, I define relation between them like this. Okay, when the x it will be increase, the y it will be decrease. Okay, and when x it will be decrease, the y it will be increase. This is my relation according to the phenomena relation between x and y. So when you build your model, you should be understanding the relation between the variables. But it is preferred you don't have more than 2 correlation to don't make any problem to this software. My recommendation, don't increase to 2 or 3 correlation between the variables, because sometimes we have a huge variables, and if the correlation it will be increased, it makes some trouble. It is recommendation from the Crystal Ball manual as well. Okay, so this is the correlation that we have between them. We have another very small item I need to clarify about the cell preferences. I don't know, it's general according to the assumption color. If you have decision variables that we have decision defined decision, forecasting, functions, and so on, it will be the mean. We take about the mean value for the distribution, decision variable, assumptions, and so on. Okay, so this is all about the correlation, fitting, and correlations. Okay, thanks a lot, and if you have any question, let me know. Thanks a lot.